for the second circuit, it's an RC circuit integration. Now we switch R with C. So now the output is across the capacitor. So for this circuit, and I'll be using the same values I used for circuit 1. So I used R 560 ohms and C 3.3 nanofarad for the first circuit. So I'll switch R with C. So now the output is across the capacitor. Input from the function generator goes to the resistor. So the same. So tau is the same for RC circuit for the differentiation and integration circuit. So tau for the first circuit is 1.84. And to set the function generator, we need to set the period to 12 times tau. So it's 22.18. And the amplitude of is a square wave, and it's 2 peak to peak. So here's the function generator.
Wait.
So for the function generator, square wave, 2 peak to peak, and the period is 12 times the expected tau, which is 22.18. Now, here's the output. So this is the input square wave and this is the output. And the same for tau, or for the time constant. So we want this part of the waveform. We'll put cursor x1 at the very bottom and cursor x2 at the very top. And then read delta y. This is the delta y. Multiply delta y by the amount of decay, which is 1 minus e to minus 1, which is the 0.632. And then move cursor x2 until delta y equals this value. Then delta x is tau. So let's apply this here. We'll turn off channel 1 and then maximize channel 2. We want this part to move it up and then maximize it horizontally, move it left and right. So we'll use cursors and then cursor x1 at the very bottom. Then cursor x2 at the very top. Read delta y, which is 1.80. Multiply it by 0.632. 1.8 times 0.632 is 1.13. Then move cursor x2 until delta y equals 1.13. Now delta y equals 1.13. Now delta x is tau. So tau is 1.98 and the expected tau is 1.84. So it's close. We do the same for the other two circuits. Let's try one more circuit. So for the second circuit, I'm using 1K with the 6.8 nano capacitor. So input goes to the resistor. then output across the capacitor. The capacitor is connected to the ground. Now this one is broken. For this circuit, tau equals R times C, and R times C, 1K times 6.8 nano is 6.8 micro. And to set the function generator, it's 2 peak to peak, and tau equals 12 times the expected tau. So it's 12 times 6.8, it's 81.6 microseconds. So here, in the function generator, it's a square wave, and the amplitude is 2 peak to peak. The period is 81.6 microseconds. Adjust the output. Use cursor X1 at the very bottom, cursor X2 at the top, and then read delta Y, which is 1.85 times 0.632, 1.16. Now move cursor X2 until delta Y equals 1.16. So now delta Y is 1.16, and delta X is tau. So tau is 6.8, and for this circuit, tau is R times C is 6.8. It's close to this one. We do the same for the third circuit. That's it.